have a good friend when I was doing my PhD in Liverpool, in Manchester, UK. I used to be friends with uh, uh, our colleagues from China, so from Taiwan, from Turkey, from Germany, European, a lot of that one, from Arab countries also. So I found out we are all the same, you know. We are all the same. We have all the same sentiment. We all have the same problem in our country. So the problem will never go on. Will never stop. The problem is how do we deal with the problem? Huh? That's what I said. You have to have an open mind to understand the whole system. Try to educate your mind first, and then you can talk to yourself. When you can talk to yourself, you can have the right answers. Believe me. You can talk to yourself. You understand how to talk to yourself. That's why I teach you how to dig a question by asking yourself. Believe me, that is scientific method. That is also religion method. Most people don't understand it. I've been digging that for more than 20 years in the religion method also. Nothing wrong with the Muslim method. Nothing wrong with the Buddha method. Nothing wrong with the Hindu method. Nothing wrong with the Christian method. As long as we believe in God. But at different level. At this level, they are arguing. At that level, they are the same. Are you with me, guys?
Yes.
But it's very difficult to talk about this with so many people because most of us are not open-minded. Even my colleagues are also not agree with me. I'll still keep teaching using this whiteboard. Why? Most of our friends are using a very nice slide, everything. Why is that so? Because I want to have a life, I want to show how the methods being done, that one, and I can ask you back whether you understand or not. That is the real learning. In the religion method, they call it muzakarah, conversation, two-way. If you just give the notes and you read it, that's one way. I can double check your understanding. And then the response from the less understand, so I comment it. So most of us, you can, that the way that you respond is not correct. So that is the real teaching. That's why I don't change, even though it's not so nice. My writing is not so nice. But that is the best method, actually. Yeah, I'm sorry for you. I don't give you a very nice line every day, because I don't believe in that one way of teachings. That is one way only, not two way. I have to ask you and you have to respond. I have to ask you and you have to respond, so I can evaluate your understanding. So, okay, I'm sorry, if I don't have a very nice line, everything. Okay, let us start today with our moment of silence and remembrance our God again, Al-Fatiha. Okay. Today we want to conclude everything, right? Start from chapter 1, we have a stress analysis. In order to do stress analysis, we have to do cut section. And before we cut section, we have to do the correct free body diagram. We release the connection. There must be some arrow there. Those are statics. So those are common things. 1 arrow or 2 arrow or 3 arrow. And at 3D, there's might be 9 arrow. Some of them might be 0, whatever it is. So that common understanding, the basic understanding, you must have that one. Cannot run away from static. It's not moving. What's the meaning of not moving? Summation of forces must be 0. Summation of moment must be 0. That's the meaning of static. It's not rotating, it's not moving. Rotating is dynamic. Moving is dynamic. And that's why in dynamic, got summation of forces is equal to MA. Moving. And static, got summation of forces go to 0. So not just remembering that one. From that fundamental, we can create equations. And then inside that body, we are learning about solid mechanics. Inside that body, we have stress. Stress is Newton over meter square. What's that? How the load is being distributed in that line, in that direction. Different direction, different value. Different direction, different value. Different ways, liquid and air. You go down the sea level up to a certain level, the pressure is the same is everywhere. The pressure is same with that fluid. But the pressure is same unit with stress. So that's how the load is being distributed in the air and fluid. But in solid, no. Different direction, different value. Different direction, different value. And then we have to find where is the highest value. That's what we do the Mohr circle. Every point there means different direction. So the highest one, highest tensile. The less one is less tensile. And then the biggest Mohr circle is the tau maximum. 2D, we have only tau maximum. 3D, we have 3 tau maximum. From that 3 tau maximum, where is the highest one? So that's the absolute one. Why we have to find the 3? Sigma 1, sigma 2, and tau max. Or sigma 1 and sigma 3, tau max. Why? Because material fail in 3 different categories. Sometimes it fail in tensile. So we have to compare sigma 1 with the yield in tensile. And why we have to find sigma 2? If the sigma 2 is negative, so we have to find the sigma 2 negative. That is the highest negative, the highest compression, not somewhere else. So we have to compare that with the yield in compression. So why we have a tau max? So we have to compare that with the yield in shear. 3 different failure types. Those are the basic understanding. But there are failure theories. What are failure theories? We have to find the Rankine stress. We have to find the Tresca stress. We have to find the Saint Venant stress. We have to find the von Mises stress, Higgs stress. That stress compared to one value only. That is theory. To make life easier. Basic principle, it can fail in 3 different tensile, shear, and compression. To make life easier, not to do these 3, what do? They provide a simpler solution. But that is just a theory. So close to that. So sigma 1 minus sigma 3 is equal to sigma y. So sigma 1 minus 3 is Tresca stress. So that Tresca stress just compared to one value instead of comparing to the 3 value. That is what failure theory. Just a theory. Are you with me, guys?
Yes.
You have to understand that one. To make life easier. Then we have a von Mises stress. What is that? The square root. And what is that inside that one? Sigma 1 square, sigma 2 square, sigma 3 square, minus sigma 1 times sigma 2, plus sigma 2, sigma 3, plus sigma 3, sigma 1, close, and then the square root the whole thing. That is von Mises stress. That is just a theory. Compare that to the 1 yield only, not the 3 yield. 1 yield only. That's a theory. Even though his theory is very close after we do a lot of testing, it's very close to the real one. That's what we call a theory. Now you understand the theory? And then we do the thick cylinder. Thick cylinder is still the same. 3 different direction of stress. 3 different direction of stress. And also can be used in failure theory. Sigma X, sigma Y, sigma Z, change to sigma H, sigma R, sigma L. 3 different direction. It's all the same. What's the difference with thick cylinder and thin cylinder? Thin cylinder, we look from outside. You are looking from direction of R. Thick cylinder, we are looking from that here. We are looking from L. So we got R direction and we got H direction. Because we know why sigma L is constant, whether 0 or A. So we are looking from H and R only. But in thin cylinder is not very accurate theory. We're just looking from outside. Outside is sigma R. We don't care about the thickness. Just every position, just the same value. But in real life, it's not the same. The thin cylinder is just not very accurate theory. Just valid for simpler cases. Are you with me, guys?
Yes, doctor.
And then we have the plastic bending. Plastic bending is above the yield. We want to make things, we want to make product, we want to make the bonnet of the car, we want to make the car window, close under all are made from sheet metal. How do we bend it? When we bend it, it must go into plastic. Then stay that shape. So that's why. How can we bend it so much? No, if I sit there, fully plastic, so we break. We must make it somewhere in between of maximum elastic and fully plastic, somewhere in between 10%, 20%, or 40% up. And when you work, you know where is the suitable. We have to do that on your own when you work. So that's different case from failure theory. We are going above failure. That is especially for metal only that have long plastic region. What is that? Like the steel, aluminum, copper, all have long plastic region, not for brittle material. So we can bend it, become plastic, and then bend it again, also become plastic. It's still not failed yet, so we make shit. So that's the purpose of plastic bending. So we must know the forward case, backward case. And then we have the energy theory. Energy theory is go to the elastic band, below the yield. So below the yield, we're talking about My over I, we're talking about TR over J, we're talking about P over A, we're talking about VQ over IT. Those are below the yield theory. All those TR, T, torsion, moment, V, and P, the one, all the theory, the one below the yield. So when below the yield part, when we release the load, we go back to zero. All this theory. You bend something, still elastic, and release it, go back straight. When I have axial loading, that will become shorter. And then we release it, go back to zero, go back to the original length. That's the meaning of elastic. So we are talking about the energy they hold inside the body, inside the solid body when we are pulling or energy there. We have twisting, torsion. Energy is there during the elastic one. Release, go back. Moment. There's energy there. That's why we come buat lastik now. Huh? Ambil rubber band with elastic something. So, do axial loading. So, axial loading. So, there's energy there. Bending also. You know the bow. Panah. Bow. So, the bending of that one is energy there. Release that one, energy is being pulled to the one, being pulled that one. So, energy, we're talking about that energy. Energy elastic. And then, the nice thing in the Castellano, they study about the energy theory. How do you find the deflection and slope at some point? The first Castellano is two-step method. The second Castellano is one-step method. You can find MDP. You want to find T dt dp. Find the deflation. To find the slope at that point, M dot. T dt over dm dot. So all before that, you must know how to do cut section static. You have to know to write the free body diagram. When you cut that one, what is the moment? The moment is constant or related to X. So this is our decision from static. We bring in solid 1 and solid 2, same again and again. And then you must know the forward case, backward case. It's how you test your mind, you test your intelligence, you test your akal. What is this topic is all about? And then you go to what is this topic? What is the limitation? What is that? And then the last topic, we talk about buckling. What is buckling? It's compression. When things are under compression, can fail by two. First, normal yield. Tensile, when it's in tensile, only yield will fail it. Compression can fail by yield or can fail by buckling. Okay. And then when we push it, and it's buckle, what is the stress when it's buckle there? So we have to know the distance there. First time that distance become moment. Then the moment again become my over I, the same again. How much the deflation there? So the formula is being given to you. When the distance is eccentric, eccentric now, So this one will also bend. So they have value there. So how do we find the stress there? The distance here is V max, you call it. Some people Y or V. There's an E there. So P times that distance. So P times E plus V. That is a moment. So that moment there you cut there, there's a moment there. Moment. So the moment here, see there, there's P there, there's a moment there. So what is sigma A, B, C then? Sigma B is only by P over A minus. This my over I is 0 because your y is 0, the middle. And then sigma A there, minus P over A, and then minus my over I. The M there is that one. What is sigma C there? Minus P over A, compression, and then this one is tensile, plus my over I. Go back to basic one. Are you with me, guys?
Yes, doctor.
Just like bending moment. Here. Put it there, P there. The distance 10 there. Cut there. What is the stress there? Do the cut section there. Got a P there, there must be a moment there. So how you got the A there? Sigma A there, minus P over A, and then minus my over I. Same thing. Only that this one is being, the free body is being drawn after it's being deflect. This is more accurate than this. This one actually, the diagram will be look like that. But we don't do that, this undergraduate. That's why I call this postgraduate stuff. We do the real thing there, the diagram become like that. Are you with me?
Yes.
When we cut here, so the length here, so difficult to find, right?
Yes, very difficult.
So this is what we do in postgraduate. We do the correct distance, not that 10 anymore. Because this one also move to the right, this one also move to the right. This one also move down. Even this one, we can do that in energy theory, not? Yes, we can find the deflection there for energy theory. For energy theory, we can find the deflection there. Look at this. We can put the dummy. Only put this is 10 Newton, 100 Newton there. 1A. So put there. So this one will bend there, this one will bend there. So this one will go to A dot. So there must be a horizontal deflection, delta X. There must be also vertical deflection, delta Y at A. Correct?
Yes.
From A to B, B to C. So how can I find delta Y? Delta Y at A. So there must be MdP. So I put a P load there. In terms of symbol. Integration from A to B, M dmdP over EI dx. And then integration from B to C, M dmdP over EI dx. This AB here, what is the M there? Inside here, what is the M? I do the cut section there. I do the cut section there, there's a P there, there's my X there, there's my M there. So my M is PX. Correct?
Yes.
So what about from B to C there? From B to C there, I do the cut section there. This is P, this is 2 meters, 3 meter. 2 meter, so you X down from B to C, X there. So what is my moment there? My moment is 2 times P, correct?
Yes.
So if I put this one, what is M dmdP? M dmdP. My M here is PX. DmdP here is dmdP is X. I got X over EI. And then dx. And then we got here I got 2P. Integration 0 to 2 here, then 0 to 3 here. And then dmdP is 2. So I got my value not?
Yes, can.
Yes, I got my value there. What is the deflection that horizontal? But this A also moves to the right, right?
Yes.
If A moves to the right, what do? I want to find a horizontal deflection. I have to have a horizontal force. I don't have. I put a dummy. Put a dummy there. What's wrong with that? Q. Put a dummy there. Q. Put a Q there. So my question now is, what is horizontal deflection? Delta AX, delta X at A. So M dmdQ for section AB, M dmdQ over section BC. So my moment is Px times 2 times 0. dmdQ is 0. Doesn't consist moment there. But here I have a Q there plus Qx. dmdQ is equal to X. For that case, for that body, even though Q is 0, so here the MdQ is 0. But here I got, what do we have here? Second part here. Yeah, M dmdQ. 2P plus QX, that's M. The MDQ is X. So Q is 0, no problem. I got 2PX to integrate. So 2PX integrate, we got 2PX square over 2EI. And then with the 0 until 3. We got a deflation not? Yes, I got a deflation. From here to that one, so I got a horizontal deflation. Just put dummy there. Are you with me, guys?
Yes.
It's how you put your understanding into things. You have to develop question and question. Make your, not necessarily just straight line. Can be any figure. Yeah? So that's about it. Yeah, that's about it. So I just want to, this is just my wish lah, my wish for you to have this thinking skill in learning. Everybody of you have it, but you don't train it to make it stay with you. Any problem that you see in front of you, you talk to yourself, us. Because us is the real thinking. What inside here you cannot say. But say it out is asking and answering. WWWH is the way to ask. You don't remember things, you ask. What did we do yesterday? And all the your CPU will collect all the memory back. You don't remember the second level. Memory is second level. You don't remember. Use your thinking to get it back. What do I learn yesterday? What did he write yesterday? He's talking about what? You're asking that all the info will come back. And then when the info come back, you ask again. This one is talking about what? Then you are digging more. You go to level 3. That equation, when you have equation, what the equation can do? How can do the forward case? How can we do the backward case? That is the digging part. You're going from digging from understanding to apply. And then you're digging more how to analyze. And then you're digging more how to compare. And then you're digging more how to make a decision. Without starting from digging by asking, without asking. Digging is asking. Without digging, do the work of digging, you're not confident to make a decision. Level 7 is decision making. Are you with me, guys?
Yes.
This is what we want you to have when you become an engineer. You can communicate in a meeting. Don't be like politicians. They have debate. Debate is totally opposite of meeting. In a meeting, you argue things, this argue thing. You propose his work, and then you compare that one. We are doing thinking skill during meeting, you know. I still remember when I was working in Texas Instrument in Kramat. I'm the one graded from Texas, going to work with Texas Instrument in Kramat, KL. And then one of my colleague, Wong, is graduate from UST Malaya. And Tan is graduate from UTM KL. We fight during the meeting, you know, I don't agree with you. That fighting is just to convince until at the end, oh, this is like that. And then we agree consensusly. That is a meeting. It's not by vote. After I explain, you agree. Still not agree, why not the work? We do this work. Until everybody is agree, that is consensus. It's difficult to do the meeting in the real, but we fight, but we open mind. Not to say that I'm right, you are wrong. To fight, to find the real things. Require higher thinking. Are you with me?
Yes.
This is what we call, when Rasulullah said, decision have to be made dengan mesyuarah. Decision have to be made with majlis syura. That's what Rasulullah said. Correct. Exactly, have to be done by meetings. But not every people are capable to do the meeting. They don't have a thinking skill. They just keep quiet listening. These are not meeting people. We have to argue and present, confront and agree and not agree, and then why not agree, why not agree, and then until the meeting gets resolved. So we do. When I was in tax instrument, we do that every single day, you know. We fight, we don't agree, and agree, we don't agree, we agree every single day, but we don't have any bad feeling toward the others. We have to solve the problem, to find the real things. That require higher thinking skills, not the notes from your engineering anymore. The note is there, but you have to bring and you have to present back. Look at this. Imagine you are an engineer. You want to decide. You want to decide to buy which material you want to use for a certain product. Let's say lah, besi dengan aluminium. Besi, aluminium. Ni besi. Buat masa sekarang, let's say 1 tan besi, let's say lah. 1 tan of besi, harga dia katakanlah RM1,000. Contoh lah, contoh. And then 1 tan aluminium, cost dia RM1,200. So, a small decision without thinking skill, you look at the numbers, straight away. Correct. So this is more expensive, we buy this one for the product, correct? Look, if you have a thinking skill, you are an engineer, you present to the board of directors. Look at this. Because I've done this. No people argue with me. Because I present it with graph, with this and that. So, people will agree with consensusly. No argument. Just to help people who don't understand. We have a thinking skill. We have to help those people who don't understand. So how do I present? I just take some finding. So this is to year 2000, 2021, 2022, 2000, 1999, 20, 2020, 2019. See that? So the price here, let's say this is 1,000. 1,000 besi. This 1,200 aluminium. This is besi. And then I plot it. I plot it. Yeah? I plot it. The price before that, and the price before that, the price before that. That's simple. This is what I call analytical thinking. And then, this besi here, even though it's harga 1,000 now, but the plot is like that. So when I present it, if you do the thinking skill, you present just that year value. So when I present it, we have to use the material this for 20 years. With this graph, by 3 years, this will be picking above that one. See that? By showing this graph, this is what intelligent people talk. This is how we have akal to talk with people. Are you with me not?
Yes.
Make people understand completely. You don't like. This is what happening to me. Because they don't understand. We have the thinking skill. We have to help them to make understand. That's why we have to present it very nicely to make them understand. They don't have a thinking skill sometimes. Are you with me, guys?
Yes.
This is what I really, really want you to have. I'm very fortunate actually. This semester, our class is very lively. Okay. Miss Ng, thank you very much. And the others, you respond to my question, okay? Regularly. Okay, appreciate it very much. Okay. So, anything else you want to ask? Okay.
Doctor really don't teach any other subjects anymore.
There's a final year option subject. This semester also teach the composite material. Maybe next semester we don't have an offer. Maybe after that we have. After that we have an option, composite material. And then also we have an option plasticity. Above that one, plasticity. Okay? Elasticity, plasticity, that one. It's all about applied mechanics. So I teach from year one is static. And then I used to teach the composite and the final year subject, that one. And then when I found they are not doing the thinking skill, I moved to third year. And then I moved to second year. And then I moved to first year. Also, it's static. I teach dynamics. I teach solid 1. I teach solid 2. So I think my option is the composite material and the plasticity material, that one. So those are until the end. So most of my students sometimes they're crying, learning with me. Most of my masters and PhD students, they are crying. I still remember in 2002, one of my students said, this girl, doing a master with me, is crying because I want to force her to understand what is the concept first before just do. She want to do. Don't know what she's doing. And then I keep arguing with her, and I keep crying, They don't know, she don't understand. And then I have to do a lot of things with her. After he finishes her masters, he got a job. I got a scholarship to do a PhD in Australia. When he do his PhD in Australia, he emailed me. I still remember that. She emailed me, thank you, Cik. Dia cakap, thank you, Cik. You know what? What are you talking to me? What are you exposing to me for the last 1 year? She said, I'm teaching the postgraduate in Australia, how to do the experimental method, how to do your experiment. Because we must understand the system first. Before we do the conclusion, we must know the analysis. We must know the experiment. Those are the scientific method. Because everybody is learning from me now, she said. This is one of the product. Crying with me because don't get the principle, because people just want to do things without understanding the principle. It's completely different from thinking skill people. We are not just end user. Some of us just want to end user only. So thinking people is not end user. So that's one of the nice story. She's now a full professor. I'm not a full professor yet. She's now a professor in one of the university in KL. I still remember her. Okay. Okay, anything else? Question? Okay, kalau tak ada, thank you very much. Thank you very much. Good luck in your life. Good luck in your study. But please use that thinking skill learning. We want to develop that thinking skill learning. Saya dah kasih banyak example. When you read things, ask yourself what you read. What is that? How is that become like that? And then when you do that, when we have a question, can you expand it? I mean, you are developing another question. That is also asking. If I do the load like that, what happens? Just now the load is vertical. What if I do the load horizontal? What happens? Said, can I find that one vertical deflation? Yes. So the vertical is dummy. So you create your own question from that question. That is the first step in developing your thinking skill. Are you with me, guys?
Yes.
This is what I call digging in learning. You learn in normal way, but after that, from 4 o'clock until 12 at night, you are digging yourself. Once you do that, I'm sure you'll be confident with yourself. The ilmu, the memory, all will be there with you. If it's not there with you, it's somewhere there in your memory. But your thinking skills, CPU, will collect them when you ask it. Believe me. I give you an example. Let's say you and me come from the same school, high school, 20 years ago. Okay? Somewhere, let's say Pahang, Kuantan. When I go to there, still remember me not? No lah, who are you? Something like that lah. Remember we go to high school and together? No, they don't remember. We don't meet so many times. And then, remember that we play football, and one day that we go to camping there, and then we go to Portison there, and then we play football there, and you twist the ankle at the beach there. And then, when the clique is coming, oh, Amran eh. And then when we know Amran is there, and then we do that, all the memories come. It's happening not to you?
Yes.
Yes, because the memory is there. It's just the matter of open the switch. This thinking skill is a process of finding the switch. Are you with me, Lord?
Yes.
That's it. It's proven. It's proven. It's proven. Believe me. I'm making this study, a lot of this study myself. Okay? So, and this is what the most precious thing that God gives to us compared to other human being, compared to tree, compared to animal. This is the one. But people don't want to find out what is that. When you have that one, treasure it. This is God-given properties. Free, you know. Okay, thank you very much. Okay, good luck in your study. Okay, I wish you good luck in your final exam. If you want some more, just communicate with me. I also given you the past year final exam test, right?
Yes.
So you can ask your friend also. You can communicate. Remember, you have to submit your project works. Sometimes this or next week or the other weeks before test. Okay. So you have to, that's just a small learning for you to communicate with your friends, how to divide the work. It's not that much the work actually, okay? You have learned about it. That to do it in proper report, you have to write something there. So, okay, thank you very much. I enjoy teaching you this semester. Hope to see you sometimes, okay, in the future. Okay, good luck. Okay, Assalamualaikum. Thank you very much.
Thank you so much,
Bye-bye.
Doctor. The chapters are all the
Thank you,
same,
Doctor.
right?
Happy New Year too. Happy Chinese New Year next week. Okay,
Thank
good
you,
luck.
Doctor. The chapters in final exam are all the same, right?
Yeah, okay.
Okay.
Thank you.
Thank you,
Thank
Doctor.
you, Doctor.
Thank you, Doctor.
Thank you, Doctor.